Hi class. In this video, we're going to be talking about some estimation methods that we're going to use for arithmetic operations. So there are pros and cons to estimation. Let's talk about the cons first. The con is estimation will not always give you an exact answer and it's not completely accurate. But the pro is if you want to calculate something really quickly, or if you just don't know how to do the calculation, if you have those exact values, you can use estimation to get you simpler values so that you can perform the operation. And sometimes it's good for multiple choice questions. And the keyword is sometimes. These are the two methods that we're going to talk about, front end estimation and relative size. And there's also some definitions that I want to go over. So an overestimate is when you have an estimate that is larger than the actual answer. And an underestimate is an estimate that is smaller than the actual answer. For the context of this course, we're going to focus primarily on using relative size estimation on our quizzes and our exams because it's typically more accurate compared to front end estimation. There are a few cases where front end could be more accurate, but in most cases, relative size is the more accurate estimation method. So we're going to use that one. Front end estimation. So it's a method of adjusting by using only leading front digits of the numbers and adjusting the remaining digits to zero to quickly calculate an approximate answer. So for example, if I were to use front end estimation to estimate the calculation below, here's what I would do. So this here is the actual calculation. That's the actual answer. If I use front end estimation, I simply keep the first values the same, 3 and then a 2, and I make everything else 0. So I simply just have 30.00 times 200 because I just kept the values the same for the front leading digits. And then I just multiply them. And I believe I simply get 600 here. And that would be my 6,000 here. And that would be my estimation pretty much. Is it close to this estimate? Kind of, not quite. Like it could be a lot closer, right? That's why I said like it's not always the most accurate method to do. From using front end estimation, we get an answer that is an underestimate. Now, if I were to use relative size, it's a method of estimating by rounding numbers to nearby, easy to work with values to quickly calculate an approximate answer. Now, here's the example here, the same one. Now, for the context of this course, here's what I want to teach you guys to do. Notice that 37.50, the largest value it has is in the tens place. So I'm simply going to round to the nearest 10. And notice that for 207, the largest value it has is in the 100 place. So I'm simply going to round to the nearest 100. That's what I want you guys to do in the context of this course for relative size estimation, okay? Just to keep it straightforward. So in this case, 7 rounds 3 up because 7 is greater than 5. So I simply just have 40 here. And here I have 200. 0 is less than 5, so it just rounds it down. So I'm just going to have 200. So I simply just have 40 times 200, which should be 8,000. Now, the 8,000 is closer than the 6,000 that we got from front end estimation. So technically our relative size estimation is a lot closer. So if we're using relative size estimation, we get an answer that is an overestimate, but closer to the exact value compared to using front end estimation. Here is a practice problem. So calculate 2.65 times 3.72. So in this case, if I use relative size to calculate that, our largest values are in the ones place. So I simply make a line here. And in this case, 6 is greater than 5, so it rounds 2 up. So I get 3.00. And now 7 is greater than 5, so it rounds 3 up to a 4, so I get 4.00. So I simply just have 3 times 4, which gives me an answer of 12. So our estimate is 12 compared to the actual answer of 9.85. So the actual answer should be 9.85 in this case. So we're kind of close, but not that close. But in some cases, it can be useful. So let's do a case with a multiple choice, for example. Like let's say you have a multiple choice one here, and then you're going to use relative size estimation to help you with this one. So once again, our largest values are in the ones place, so I simply draw a line here and here. The 4 is going to round since 4 is less than 5, it's going to round the 6 or down. So I guess we're just going to leave the 6 the same, make everything else 0 here. So we got 6.00. And in this case, since 8 is greater than 5, it's going to round the 7 up by 1. So we're simply going to change that to 8. So we basically have 6 times 8. So our answer with relative size estimation is 48. and 48 is going to be closest to D, which is 50.31. So that's an example of how relative size estimation can be useful. And again, we use this when we can't actually calculate this using our own arithmetic skills. If you are able to calculate 6.45 times 7.8 manually, then by all means go ahead and do that. But if you want to just get a fast answer, or if you can't calculate it manually, then you can just use relative size estimation. Okay, for this example here, Jane spends $19.99 on lunch every day for 5 days. How much does she spend during her 5 day work week for lunch in total? So in this case, it would be appropriate to use relative size estimation to get an approximation. So if I were to find out exactly how much she would spend in 5 days, I would have to take 19.99 and multiply it by 5. Now, for some people, this is easy, but for some students, it could be quite difficult to do. And a faster method would just be to use relative size, let 19.99 be 20, and then just multiply it by 5 and get a nice estimate for an answer. So in this case, 100. So in this case, a rough estimate would be Jane spends around $100 for lunch over her 5 day work week. And this would be an appropriate use of estimation because we're just getting an approximation of how much she spends for lunch. Now, for this question, estimation probably shouldn't be done, and I'll show you why, because it depends on context. So, Dr. Smith prescribed a daily tablet containing 9.2 milligrams of medication for his patient. If the patient takes this tablet every day for 7 days, how many milligrams of medication will he take in total? So, in this case, I would have to take 9.2 and multiply it by 7 to get the total milligrams for 7 days. Now, if I were to round this, I would just let 9.2 be 9 and just times it by 7 to get a rough estimation. And that would get me 63 milligrams over 7 days. However, because medication, the dosage has to be important, by rounding this to 9, I'm actually now providing the patient with an underdosage, and that could make medication less effective. So in this example with like spending money on food, that's an appropriate time to use relative size estimation for a quick answer. But if we want to be quite exact when administering something such as medication. So this is the case where you probably shouldn't use relative size estimation to get an answer, and you probably should just calculate it um, by multiplying the exact decimal value. And hopefully that gives you an idea of when it is appropriate to use estimation and when it isn't, and how when we do use it, it can be really helpful.